We're now going to look a little bit closer at the change of variables formula, how to use it. And as usual, we'll do this by taking a look at an example. So the example is not terribly hard, but it's hopefully instructive. So it's this guy here. So what does the change of variables formula say, or the composition rule, you could also call it? Well, you can write it in two ways. So one way would be to write it as x tends towards a, f g of x. And of course, you have to say that the range of g should be compatible with the domain of f, blah, blah, blah. Let's just assume all of this holds. Then you get this thing here. That's one way of expressing this. Let's call this 1. And another way of expressing this is to say that, well, if lim x tends to a, g of x is equal to b, and lim u, f of u, when u tends towards b is equal to L, this implies that lim x tends towards a of f of g of x is equal to L. So these two ways are not equivalent, but both are true and both make sense, but they're useful in slightly different situations. But here we can use both. So let's try to use both. Here, I would say that 1 is the more convenient, because now we know that, well, so the outer function here is, well, f of u being u squared. So you can say this is the outer guy, and the inner guy here is 4x plus 1. So here, if we use this rule, this will look just like this, 4x plus 1. And then, well, depending on how careful you are in the rulebook, so you can break this up even in smaller pieces, chunks, you're saying at the very end that limit of x as x tends towards 1 is 1, and the limit of a constant as x tends toward 1 is the constant. Or you can just say that, well, it's clear that this will go to 4 times 1 plus 1, and then you have the square here, and now you'll have 4, 5 to the square, and you'll get your 25 in the end. So this is one way of doing it. What would another way be? Well, let's try to use this thing here. So we're still trying to compute the limit as x tends towards 1, 4x plus 1, like this. But now we want to do basically a change of variables here. So up here we kind of thought of this as compositions, and now we want to think of this as a change of variable. So what I do is I can write here lim, and then now I pass to u tending towards something, and I write here that all of this is my u. And it's clear that if x tends towards 1, u will tend toward 5. So I can do this, and then I can do u squared like this. And now this becomes 5 squared equal to 25. And how is this chain here of equalities justified? Well, backwards. Because what am I doing? I'm really making this computation here first. So what I'm doing is I'm actually computing that this thing here is equal to 25 when this is a 5 and my f of u is u squared. Then I'm combining this with the fact that, well, who's my u? My u is the same as my g of x. So I'm combining this with the fact that here I'm checking that when x tends towards a, which is 1, this expression goes to 5. And this gives us this connection here. So here I'm checking basically the assumptions up here. Probably I should write here also lim x goes to 1 for plus like this is equal to 5. So we have this in parentheses, feed it in here in combination with this rule. And then I know that whatever limit I'm getting here, this will also be the limit that this guy has. And in practice, when I write this up, if I'm a bit careful here, I would do something like this. And then I'm done.